Hello friends, we are still not employed by FAANG company, so let's not stop lead coding till we get there. Today we are going to do a very important problem, climbing stairs. Though it's a lead code easy problem, everyone should do this problem because it gives you a really good introduction towards dynamic programming, and this is one of the core concepts that a lot of companies likes to ask. So let's understand the problem statement. We are climbing the staircase and it takes n steps to reach to the top, and every time we can either climb one or two steps, and we need to show that how many distinct or how many separate ways can we climb to the top. We are going to understand this problem with three examples. Suppose we are only given just one step and we need to climb that one step. So how many distinct way we can climb that step? Only one, because we just take one step and we are already at the top. So there will be only one distinct ways we can climb to the top. Suppose we are given two distinct steps and we are trying to reach to the top. So this is our first step and this is our second step. The distinct ways are actually two. One way is we take first step at the first step and we take one step again. So this would be our first approach. And second way, we can directly take two steps, because remember, we can either take one or two steps. So if we directly take two steps, we will still reach at the top. So in this case, we can do it in two distinct ways. For the third example, suppose we are given three steps and we need to find that how many different ways we can climb that. Apologies on my painting. I'm not the Pablo Picasso of this generation for sure. The first way we can climb over here would be the most simple one, that we take one step each time to reach to the top. Second way would be to take two steps directly at the beginning and then take one more step. And the third way is that we take one step at the beginning and then we take two steps. Other than that, there are no other possible ways to reach to top apart from these three. So the total number of different ways we can reach to the top for the staircase number 3 is actually 3. And now that we understand that what we need to calculate, let's see what could be the different approaches. Our first intuition is that if we start at the step 0 and suppose our n is equal to 5 that we need to calculate, if we take the decision that at every single level we are either going to take one step or two steps, and then when we reach to number 5, we will calculate that how many distinct ways we took to reach to value number 5, and then all the combination of all those distinct ways would be the separate ways we can reach to 5. So that would be our answer, and this is the most primitive approach we can take. So let me show you how it would look. So at the beginning, at value number 0, we have two possibilities. We can either take one step or we can take two steps and we can reach to the second step. Suppose we only take one step, then again we have two possibilities. We can again take just one step and we will reach to 2, or we would take two steps to reach to the step number 3. Again same. So over here we will reach to 3 and over here we will reach to 4. And now over here we would reach to 4. But notice that at the 4 we only have one possibility. We can only take one step, because if we take two steps we reach to 6, which is higher than our given input. So we can only take one step, and now we have reached to the final point that we can reach to. But at the 4 we still have, and even at the 3 we have possibility to reach at 4, or we can take two steps directly and we can reach to 5. So over here again we end our possibilities, but at value number 4 we would take one more step and we can reach to value number 5. Now at this value 3 we still have two options. We can either take one step, we would reach to 4, again we take one step, we would reach to 5, or we can take two steps directly and we can reach to 5. Now we have exhausted all the possibilities from 0 to left side of the subtree if we take the first step as 1. So now let's explore the possibilities on the right side. Notice that at all the elements where I have done the square, or number 5 shows a distinct way. So suppose for this one, the distinct way would be just to keep on taking one step each time. For this one, we are taking one step up until the third step, and then we are taking the two steps. So if we calculate all these values, the number of different ways we can do this is 1, 2, 3, 4, 5, 6, 7, and 8. So based on this, we can determine that there are 8 distinct ways we can take if we are given the n is equal to 5, and if we want to climb the 5-step stairs. So we can have a recursive function that at every location of n would call itself for I plus 1 and I plus 2 while I is less than or equal to n, and we would be able to reach out to this solution. But the issue with this solution is this is highly inefficient. And if we see over here, at any given node, we are making two decisions, and based on those two decisions, we are again making two decisions down the line. So pretty soon, if our value of n goes high, we would be running out of the possibilities, and the time complexity for this approach is actually 2 to the power of n, where n are the number of nodes, or in this case, number of stairs. But this is a pretty heavy time complexity, and we should avoid it in all cases. So let's see that what are the better approaches we can take. The first approach we can take is actually to reuse the work that we have already calculated. If we see this graph, it becomes pretty evident that we are doing a lot of repetitive work every single time. Suppose if we just take this left side of the route and we have calculated the results up until this point, we know that whenever we are at value number 4, there is only one possible way to which we can reach to the top. And we are doing this work again and again and again at different locations. Again, same thing happens when we are at value number 3. If we are at value number 3, there are only two distinct possible ways we can reach to value number 5. So even when we are at value number 3, suppose we have calculated that over here when we are at value number 3, we only have two distinct ways to reach to value number 5. Why are we doing all of this repeated work over here, then again over here? This could be avoided, and same can be avoided for the work done at value number 2. We calculate towards this route and we calculate all the possibilities. So we know that from value number 4, there can only be one distinct route. From value number 3, there can only be two distinct routes. And from value number 2, there can only be three distinct routes possible. So we can use this to our advantage. If we know that at value number 2, we can only have three possible different values, we can directly use that over here and we can get rid of all of these values, because we know that at value number 2, when we reach to the second step, there are only three distinct possible ways to reach 5. Again, same thing would apply over here, that at value number 3, we know that there are only two distinct ways we can reach to 5. So after the first step, whenever we reach at the third step, we can directly say that there are only two distinct possible ways we can reach to 5, and we won't have to do all the calculations. Same over here, whenever we reach at 4, we know that there is only one distinct route we can reach because we calculated it over here. So we can again get rid of this step. We will simply put it over here and we can just say that there is only one distinct ways we can reach. So using this, we are able to avoid lot of extra work that was being done. So let's see that what would be the approach for this solution would be, where we are storing all the results that have been previously calculated in some sort of an array, and we are going through the nodes. So notice that we are only going through the nodes once, and then whenever we encounter those nodes again, we are using whatever values we have stored beforehand and we are reusing that. So the amount of work being done is actually pretty small. And if we see the time complexity for this approach, The time complexity is actually big O of n, because in one single iteration we are able to determine all the distinct ways that we can reach to 5, and then we are just reusing those values at different positions in the given loop. And if we see the space complexity is also big O of n, because we will have to create some sort of data structure to store the values of all the distinct ways we can reach to 5 at any given location. If we consider this from our brute force approach, this is actually a much better improvement, but can we still get a better result? Suppose our given value n is equal to 4, we can represent it like this. And now let's try to understand the logic behind that. How can we calculate that how many number of different ways are there to reach 4? First, we have to determine that what are the direct elements or direct values from where we can directly jump to 4. So we know that we can either do one step jump or two step jumps. So from 3, if we do one step jump, we can directly come to 4. And from 2, if we do a two step jump, we can directly come to 4. Now, this is a really important thing to consider. What this essentially is telling us that no matter how many different ways we can reach to this value 2, if somehow we can reach to this value 2, all of those ways would allow us to reach to value number 4 directly. So let me show you what I mean. So we know that there are two distinct ways to reach to 2. Our first way is we reach to 1, and then from 1 we reach to 2. And once we are at 2, we can directly go to 4. Now second way to reach to 2 is that at the beginning we directly take two steps forward and we reach to 2. Once we are at 2, we can directly go to 4, and this would also be a distinct route. But in both the cases, the common thing is that we found out the number of times we were able to reach to 2, and in both of those cases we ended up at 4. Again, same thing occurs when we consider the value 3, that we know that from 3 we are just one step away to reach to 4. So basically all the routes that can lead up to us to reach to value number 3 can lead us to reach to value number 4. And let's take an example for that as well. So from the beginning we can go to 1, then we can go to 2, and then we can reach to 3, and that would lead us to 4. So this is one possible route. Second possible route is that we can directly go to 2, and then we can go to 3, and from 3 again we will be ending up at 4. We initially start at 1, so we take one jump, and then we take two jump to reach to 3. Then we would be able to reach to 4. So in both the cases, essentially once we are at the value either 2 or 3, we end up being on this value 4. So the moment we reach to element number 2 or element number 3, we can say that from there we can directly reach to element number 4, and we cannot go anywhere further from 4, because there does not exist any step over here. So we end at 4, and the number of distinct way we can reach to 4 would actually be the summation of the summation of number of different ways we can reach for value number 2, plus the number of different ways we can reach value number 3. So suppose we define that we need to calculate that how many distinct ways we can reach to 4, and this dw represents distinct ways to reach 4. We can calculate this as the distinct ways that we can reach to value number 3 plus the distinct ways we can reach value number 2, and summation of these two values would lead us to the number of distinct ways we can reach to value number 4. And this is a really important property, and based on this we would be able to solve our dynamic programming solution. So let's clear this up a little bit. Basically in our algorithm we will keep track of two values, uh, value number one jump and two jump. So one step jump and two step jump, we will keep track of these two, and the initial value would be that for one step it would be 1, for two step it would be 2. And we can just put a condition that if the value of n is equal to 1, we would just simply return 1, because that would be our base case, and we can't go any further than that. And now we have the values for first element and second element. So we will start our loop, and in our loop we'll start it with value number 3 all the way up to n inclusive. The reason we are starting it at value number 3 is because we have already calculated the results for value number 1 and value number 2, as value number 1 would just be 1, and for value number 2 the number of possible ways we can find would be in this parameter 2 jump. Now inside the loop we will calculate this property. So we will simply do a total of whatever the value of 1 plus 2 we have. So we need to update the value for 1 and 2. In order to update the value of 1 and 2, we need to first understand that what value number 1 and 2 represents in our given example. So 1 represents the element, the position of that element from where we can, if we just take one jump, we can reach to our ith element. So if we are calculating that I is equal to 3 and we need to calculate the values of 1 and 2, 1 originally 1 would be here and 2 would be here, and now we will do a total, and total will give us the value for element number 3. Once we are done with this and once we are going for the next iteration, in the next iteration we will need to update the values so such that this 4 gets the value of 3 and 2. So 2 would be jumped over here, which means that 2 would receive the whatever the value of total we calculated of this 1 plus 2, and our value 1 would jump to this position, and it will take whatever the value of former 2 we had. So the new graph would become like, for value number 4, this would become the 2 and this would become the 1. And when we are inside the loop, we will do a total, and again we will repeat the same process, that we will jump our 1 over here and we will jump our 2 on this position. So we will get the whatever value of total we have, we will put it in the 2, and yeah, at the end of the loop we can return to. So over here we would define 1 is equal to whatever value of 2 we had, and 2 is equal to whatever value of total we have. And at the end of the loop, we will just simply return whatever the value of 2 we found as our result. And we can simply return 2 over here. Now let's calculate the time and space complexity for this approach. The time complexity, the time complexity would be big O of n, where n represents the number of steps that we are given. And for the space complexity, we can calculate in big O of 1 time, because other than storing couple of parameters, we are not using any additional space. So this would be a pretty efficient solution. There is also one more solution that provides the answer in actually log n time and also constant time, but the thing is those are pretty mathematical and they, in my opinion, does not serve the purpose of checking your computer related knowledge. So even in the interview, if we come up with this approach and if we show that we know dynamic programming, I think this would give us an edge over other candidates, and this would be sufficient for us to prove that yes, we are more familiar with computer science related concepts. And yeah, we might not be up to date on mathematical concepts, but this is not where what the FAANG companies are judging us on. Now let's move on to coding. Okay, so first of all, we are going to create a condition that if n is equal to 1, we will just simply return 1. And now let's define two parameters for one step and two steps. So we can say one step and we can initialize the value as 1, and we can say we can create a variable for 2 steps, and we will initialize the value as 2. And now we will create a for loop, and we will create a for loop starting from the third position, because we already have the results for n is equal to 1 and n is equal to 2. Well, I is less than or equal to n, I plus plus. Inside the loop, first of all, we will just create a variable total to store the sum of 1 plus 2. And with every iteration, we need to update the values of 1 and 2. So 1 will become the whatever value of 2 we have, and 2 will actually be the total value. And at the end of the loop, we can simply return the value of 2. And this should define the total number of distinct paths we can take. Let's try to run the code. Looks like our solution is working. Let's try to submit the code. Let's try to submit the code. Yeah, our solution is actually 100% faster than all the other Java submissions, which is pretty good to have. And I hope you like the video. Let me know what kind of videos you want me to do more, and I will be doing bunch of other videos on dynamic programming, so it would become more evident, and we will be able to grasp the dynamic programming concept together. We are not gonna stop till we clear FAANG. So yeah, let's get working. Thank you. Bye.